Hey guys, here again with you. This time I'd like to go over how to graph some trig functions and then just one of the types of identities that you're going to need to use for the AP exam. So let's take a look at some of these graphs. Now, some of these you're going to have to memorize, right? You just have to know how to graph sine and cosine. So here are our graphs. Now, if you want, pause it, read over that first thing, but I'm just going to quickly go over some of these because I want to make sure I get through all of these in a timely manner. Just letting you know, you're really only using the unit circle. You're using like the edges, right? Pi 0, pi over 2, pi, 3 pi over 2, and 2 pi. And sometimes you're going to use plus or minus pi over 4 for the tangent and cotangent graphs. Let's take a look at what they look like. So we have our sine and cosine graph here. So sine, and again, this should be reviewed from your pre-calc class. Sine starts at 0 and goes through pi and 2 pi and goes up like that, right? Has an amplitude of 1. Oops. Okay, let's go like this, like that, right? There's sine. Okay, now cosecant is 1 over sine. So cosecant is directly related to sine. Well, not directly, I guess inversely related to sine. If you take and basically every time it hits the x-axis, we're going to have an asymptote like that. Boom, boom. If you had me for pre-calc, you probably remember this. We did this thing called step-by-step graphing where we did this. And now every time you go up like this, you're going to have a parabola that goes up. If you're down here under the x-axis, you've got a parabola going down. And there's cosecant. Okay. Easy as that. All right. Now let's look at cosine. Okay, cosine. Cosine starts up here, goes through like this. All right, so it starts, it goes through, it's 1, and goes up and ends at 2 pi. Goes up, ends at negative 2 pi. All right, looks like a W. W, cosine W. All right, and then secant. Secant is 1 over cosine. So it's going to do the same thing that we did with cosecant. Cosecant. We're going to have these asymptotes everywhere we have our x-axis, where we cross our x-axis there, because it can't be equal to 0. And then if it's underneath the x-axis, we're going to make a parabola going down that way. Above the x-axis, below the x-axis, above the x-axis, and so forth. Boom, that's it, done. Cosecant, sine, cosine, secant, cosecant. All right, let's take a look at tangent, cotangent. Those are a little bit different. Tangent is sine over cosine. So this one's kind of tricky here. What this is going to look like is we're going to have, I know, I'm making funny sounds. Oh, let's go pink. Ooh, pink's nice. Tangent, pink. All right, we're going to have a asymptote, vertical asymptote pi over 2, and one at negative pi over 2. And then this guy's going to look like a cubic, kind of. It's going to go like this. Boom. All right? And then they're periodic. So they keep going in the same manner, and they keep going and going and going. Energizer Bunny. I use pink. See, there you go. So it does the same thing all the time. Let's use purple. So purple for cotangent. Now, cotangent is going to look a lot like tangent, only we're going to move the asymptotes. So now the asymptotes aren't at pi over 2. They're at 0 and pi. That should make sense because cotangent is cosine over sine, and tangent is sine over cosine. So cosine can't be equal to 0 at pi over 2. Sine can't be equal to 0 at 0 and pi. All right, so we're going to do the same thing we did here. It's going to go up this way, down like that, and then like that, and it's periodic. It's going to do the same thing each time. All right, there you go. Tangent, cotangent. So you're going to need to know those graphs, especially sine, cosine, and possibly secant, cosecant, tangent, and cotangent. But sine and cosine are very, very important. All right, so remember these last two, they have a period of pi, so they're a little bit different than the other ones. Okay, so I've got this grid here. You're going to need to be able to graph any sine or cosine or trig function that's in this form right here. Now, it seems more difficult than it actually is. Just remember that we're just shifting. We're just doing adjustments. So if we have sine and we have a number out in the front, then we're just increasing its amplitude. If we have a number, if we add d to that, then we're just shifting it up or down by that much. If we're adding a number inside, then we're just shifting it. Left or right. Okay, and if we're multiplying by a number, then we're scaling it, either stretching it in this way, which is going to change the period, or stretching it out that way. So I've given you the list here of period differences and how that changes based on the variables. You can memorize that if you want. You can just kind of just make sure you're understanding what we're doing here. And I know I'm going pretty fast, but I think that if you just remember them as adjustments, then it's not as difficult as memorizing this whole table. But the table's there for you. So let's take a look at doing a couple of these here with adjustments. So remember that I said that the 5 here, okay, the 5 is going to change the amplitude. So we've got an amplitude of 5, and this negative is going to flip what we started with. And this 2 is going to change the period. All right, in this case, the period is going to be 2 pi over b. b in this case is 1/2. So my period is 4 pi. All right, so what does that look like? Well, cosine, normally cosine, and this, I just like to do this so I know what I'm starting with, okay? Cosine normally looks like that. Well, I've got to flip it and make it down to 5. So it's going to start here and it's going to go up. It's going to go like this and then like this. Now, it's not exact. I'm just saying that's essentially what's going to happen. Okay, so let's go ahead and do that. So since it's got a period of 4 pi, cosine starts here and ends at the period on the same level. Halfway between that, it's going to go up to its max, which is at 5. Halfway in between that, it's going to cross the x-axis. So I'm going to go like this. Like that. That's it. There you go. We graphed it. Not too bad, huh? All right, let's take a look at the next one. Sine. I like that pink color. Where's that pink color? Oh, there it is. Okay. So sine of 2t for t minus pi over 2. So what we have to do is we have to take and factor out that 2. So we can kind of see what that phase shift is. All right, so our period is 2 pi over b, which was 2. So our period is pi. And we have an amplitude of 1. Okay, so we've got sine. Now, normally sine's going to look like this, right? Sine's going to look like that. Okay, but instead of being here at 0, we're moving everything over pi over 4 units. You know what I'm going to do first before I do that? I like to do one step before I shift it over. Now, shifting over is tricky, so I'm going to do this before I shift it over. I'm going to, using some lime green here, I'm going to apply the period to this guy, and then I'm going to shift it over. So the period is going to be, here's pi. So the period is pi, so it's going to end here. It's going to end here. Halfway between there, it's going to go and cross the x-axis. And then halfway between there, it's going to go up, then down, like this. Okay. All right. That looks a little high. Let's try that again. That's all right. Okay, so this is not my answer. The green one is what I have here is sine of 2t. What I need to do is I need to shift it over pi over 4 units. So now I'm going to go back to my pink here, and I'm going to shift everything pi over 4. So notice this is in pi here, so let me zoom in here. This is pi, so each of these units is pi over 4. So all I'm going to do is take all my major points, and I'm going to shift them over to the, oops, not left. I'm going to shift them over to the right. All right, I'm going to shift them over to the right. Shift it over to the right. Okay, everything's shifting over to the right. So now it's going to look like this. All right, because I shifted it over to the right, and now I've got my answer. Okay, so there's my graph for that. So again, we're just shifting and scaling remember the period, and I think you'll be fine with that. I don't think there's going to be too much of that on the AP exam, but this is review and you might need to know it. Okay, last thing I want to go over is using what we call the Pythagorean identity, and this is really the only major identity that you're really going to need and make sure you memorize for the AP exam. So let's go with another fun color. Let's go orange this time. So the basic identity is sine squared plus cosine squared equals 1, right? Sine squared plus cosine squared equals 1. So let's go ahead and use the Pythagorean identity to rewrite this problem. 2 cosine theta minus sine squared theta equals -2. Let's use that to rewrite it in terms of one trig function. So I see a sine squared there. I'm going to change that. I'm going to change that sine squared to 1 minus cosine squared. Now I get that because it's kind of like if I took cosine squared and I subtracted it over here, subtract, then I'm going to get sine squared equals 1 minus cosine squared. All right, so you got to recognize that too. That comes up a lot. Equals -2. So I'm going to get I'm going to multiply everything by let's do that here. So then I'm going to have cosine squared plus 2 cosine theta minus 1 equals -2. Nice. All right, so now I have to add 2 to both sides because I can't. It looks like I'm going to need a factor. My favorite mathematical F word. Factor. That's what I say when I get mad at math. Factor. So we're going to factor that, and then we're going to get cosine theta equals -1. We look on the unit circle, and that's only in one place between 0 and 2 pi, and that is in pi. All right? So you can use your calculator to verify that if you would like, but that is some basic trig that you are going to need for the AP exam. Boom! Talk to you later, guys. Or I don't know if I'll talk to you. I don't know if I'll actually talk to you. Some of you I will. Some of you I may never talk to in my life. But you know what? Have a good day. You earned it. Catch you later.